This lecture is a discussion of measurement and is based primarily on pages 174 to 178 in Essentials of Nursing Research by Paulett and Beck. In addition, it has qualitative research information on pages 295 and 296 on chapter 17 about trustworthiness in qualitative research. So altogether, we have 5 pages of your textbook that are covered in this presentation, which may indicate to you the importance of it, as we have many slides to cover. Our objective in our course is that you will be able to examine components of qualitative and quantitative research designs, and this part of the design is measurement. This is found in the methods section of your any research report. I want you to be able to identify the level of measurement found in any specific study and then critique the validity, reliability, and trustworthiness of the data that was measured by at the end of this presentation. So in nursing, we use a lot of research instruments. They actually become assessment instruments in our practice. Many things we use, such as the Braden scale, first started out as something that was used in research and then was adapted and adopted in nursing practice. So much of what we're talking about today really matters because as a practicing RN, we use assessment tools to measure various risks or to measure occurrences, various health events in the life of our patients. So understanding how reliable and valid those instruments are is essential in the life of the practicing RN. So finally, a topic that you all can apply immediately to your practice and understanding. Measurement is defined as assigning a numeric value to any kind of measure. You have to include the rules for how you're going to count and score that. And in our activity, our application activity, you'll see how that sometimes can be challenging. And researchers then report the psychometric properties of any instrument they're using by reporting validity and reliability statistics. So the great thing about defining measurement is that once you've defined it very clearly, you can repeat it and measure it the same way again and again. That's why various tools that you use in practice come with instructions on how to use that and how to quantify the different things that a nurse observes in their practice and in their assessment. This minimizes the subjectivity that can come with assessment, for example, and allows us to communicate between shifts with each other in our profession or between researchers. There are 4 levels of measurement, and you will have some practice using these. The first is nominal, which is the lowest level, and we just put things in one category or another. Nominal comes from the word name, so remember this is simply a name that's given a number. Ordinal has to do with ranking. It has limited math operations. There's very little relationship between the different numbers. They're just placed in an order. They don't have a specific space in between them. And so you cannot say that one part is twice the other or 3 times the third. They're just simply placed in order, like making a line. Interval data has a specific distance between things. These are usually done with educational and psychological tests, and they're categorized and also may be ranked, but there's a little more statistical analysis involved in this. And finally, ratio is our highest level of measure, and this is categorized because it can have a meaningful and rational 0, and ranked and distances between each measure are considered equal and known. And so this is usually what we think about measuring. When we use, for example, a yardstick, that's a ratio measure. When we use a tape measure, that's a ratio measure. A scale is a ratio measure that we weigh on. So the most scientific measures are considered ratio, and these are the highest levels that we have. So let's practice. Get ready to pause the slides so that you can see if you can identify the level. In a study of gender differences on early recovery from cardiac surgery, there were several psychosocial scales used, including a 5-item social support scale and a 12-item activity status scale. What level of measurement do you think that is? Go ahead and pause your slide. Make your best guess. If you said interval, you were correct. This is because the distance between can be specified, and because this is a psychological test that also gives you a clue, and there would be psychometric properties reported for this kind of item. Let's try again. In a study of the effects of traumatic events and social supports on adolescent self-health assessments, self-health was measured on the following scale: poor, fair, good, or excellent. Pause your slide. Ordinal is the measure. I hope you answered correctly, because that is the ranking of these based on standing. If we go back, you can see there's no known difference between poor and fair, good and excellent. So this is just a lineup, and that is why those are ordinal. Here's our third one. In a study comparing healthy subjects and patients with COPD, healthy subjects were labeled 1 and those with COPD were labeled 2. Pause your slide. Resumed. Okay, here's the level of measurement, nominal. This is the lowest level. People were just given a number based on their name. In a study of the effect of oral support on preterm infants' nutritive sucking patterns and cardiopulmonary functions, the outcomes were measured were sucking bursts, numbers and duration of pauses, and heartbeat. So go ahead and think about what that would be: sucking bursts, numbers and duration of pauses, and heartbeat. All right, hope you've got it. Here it is, ratio. This is our highest level because remember, there's a meaningful zero. You could have no heart rate, and we can look at the distance between that. We can use time, for example, as a measure in these. And the duration of pauses, time has a real 0 and is specified based on seconds, minutes, and hours. So those are all ratio measures. So what we want to do when we are working on in a research project, what we want to see is the researcher choose the highest level possible. For example, you could choose to measure people's blood pressure and just record it as high, normal, or low. That would be a nominal measurement. But if you use the actual reading, which would have a true 0 and millimeters of mercury in between, that would be an interval data. So it'd be much better to collect data as interval. It will give you more opportunities for the research analysis of it if you record it that way. Later on, you can convert it. Notice data can be converted. It could be converted from interval to nominal, but it's very difficult to take nominal data and convert it to interval. So you can always downgrade your data, but it's very difficult to upgrade it. All right, so let's consider measurement. We talked about that in our data collection, the what, how, who, where, and when of your measures. And so just to review that instruments facilitate the measurement. You can use an existing instrument or develop one, but there's a lot of practical considerations in how we measure what we do. And this next section, we're going to focus quite a bit on whether our measures are reliable and valid. First of all, though, you need to know this term, error of measurement. That is the obtained score, the measure that you do, equals the true score plus or minus the error. So, for example, if we measure people in height in inches, we might measure someone as 5'2". If we used centimeters or fractions, the person might actually be 5'8" 2 1/8 or 5'2.5" or 5'2". So there may be some error if we use simply feet and inches. Our error could be plus or minus an inch, for example, and that would be our level of error. If we used instead centimeters or millimeters, we would have a lower amount of error because it would be closer to the true measure. So situationally, things can be contaminated. What if a person stands up straighter for one measure than they do the other? And there can be all kinds of ways that administrating that measurement could vary. What if you are measuring someone really tall and you're much shorter than they are? You may have difficulty, unless you stood on a stool, to read that height measurement perfectly, for example. So there's many reasons that there are errors in measurement that the researcher and the nurse, for that matter, tries to control. Let's talk now about reliability. It has to do with how consistently an instrument measures what it claims to measure. And this is also known as accuracy. So if you think about reliability, you can also consider that how accurate is a term. So the stability, equivalence, and internal consistency are what make up the reliability of an instrument. But the important thing to know is all this evidence that is supporting the accuracy of the instrument or its reliability is only supporting. It's not proven or demonstrated. So all of these aspects are relative. So this tool, for example, can be relatively more stable than another tool, but that doesn't mean that this is a stable tool and this one's not stable. Things are just more or less stable, more or less equivalent, more or less internally consistent. So this is another example where research is not as black and white as many people think. Let's talk about stability first. That's the extent to which the same scores are obtained on separate occasions. So what I want you to remember when you think of stability, think of test, retest. When you see in an article that someone has done a test, retest, you know they're looking at the stability of their measure. And this is often reported with a reliability coefficient. So I'm not going to ask you to understand the statistical explanation of that, but know if you see a reliability coefficient reported, that has to do with the stability of the measurement. It has nothing to do with the significance of the findings. So that's where people often go wrong, is they see a high reliability coefficient and they think that the findings are really reliable, when in fact it just means that the measures are stable. Internal consistency is the extent that all the subparts measure the same characteristics. When you think of internal consistency, I want you to look for this term, Cronbach's alpha. This is a measure of internal consistency that's reported, and it's reported between a 0 and a 1. Generally, if it's over a 0.7, it's considered internally consistent. However, the higher that number, the more consistent and that an instrument is. So we're looking for the highest numbers possible in this number. And once again, this has nothing to do with the significance of the finding. It just has to do with the consistency of the results. Finally, equivalence. This is about an observation, and it's about two different people. If two different people measure the same thing and get the same result, then we call this more equivalent. So there's always the risk that the person measuring will make an error. But when two people measure, get the same answer, then you can say that we're more confident in the equivalence of that measurement. So once again, the desire for the reliability statistics are 0.7 or higher, and we talk about the strength of their measure to test a hypothesis. So obviously, you can't make any claims about a hypothesis if you aren't taking reliable measures. And so this is what's important in these. Let's take a look at this. Here's an example. Observational coding system to classify behavior of people with dementia. There's 2 versions, and 2 groups of raters obtained a 78% equivalence. So that could be reported as a 0.78 equivalence. And this is an example. When they say equivalence, you need to think about the word inter-rater reliability. So here, this measures test, retest, testing the Wong-Baker Faces Scale for pain on mature adults. They tested, then they waited 3 days, tested again with a 0.70 correlation. So this is an example of, with time, is their stability of the measure over time. So test, retest, stability example. And then we have internal consistency, which is measured with the Cronbach's alpha. Here, multifactorial leadership questionnaire with 70 items was used to study the relationship between leadership style and outcomes. The subscales on this multifactorial questionnaire, so there's many factors of leadership measured. The consistency of those scales was between 0.68 and 0.89. And so this would be considered generally an internal, having an internal consistency in the instrument. All right, now we need to speak about validity. Validity is the degree to which an instrument measures what it's supposed to measure. And there's 4 broad categories of validity: face, content, criterion, and construct. We're going to go through each one and give an example of that. Face validity means that when you read an instrument, does it look like it measures what it's supposed to? And this may sound very obvious, but if you're measuring pain, it shouldn't be asking, it shouldn't have questions unrelated to pain. It needs to look like what it's measuring. Content validity is based on judgment. Content validity is determined through expert analysis. Does the instrument capture all elements of a construct being measured? So when you see something talking about a group of experts analyzed an instrument, when you see that phrase, you know that means they evaluated the content validity of an instrument. Criterion-related validity is, when you think of criterion, I want you to think physical science. Criterion-related validity means that there is a physically observable gold standard that you can measure your instrument to. So it can either be predictive. So here we might have high cholesterol, inactivity, obesity, can be predicted of an MI, a myocardial infarction. So if people are more likely to have a myocardial infarction who have those characteristics. So it's a physical science. You might have some criterion that may be less specific, but in the end, your outcome is measurable and observable. The other kind of measure is called concurrent, and this means that you might, for example, if you measured SpO2 in someone's finger, you might not know how much oxygen is getting to heart tissue, but by measuring that SpO2, that peripheral SpO2, you might be able to make an estimate of how much oxygen is getting to other tissues in the body. So it's a measure that's done at the same time, and it's meant to be a proxy for what you are actually interested in, the criterion that you're really interested in. But it's very difficult to find valid external criteria with criterion validity. Construct validity, on the other hand, is for human science. These are abstract attributes, and what you can use is another group, a comparison group, to describe a specific construct. and make sure that that instrument is really capturing all of those elements. And we do this with a statistical analysis called factor analysis on the instrument. So just know, if you're reading about construct validity, it should be talking about a less measurable construct. All right, here we look at some examples. Here's an example of face and content validity. A functional performance inventory measures the performance dimension of functional status in adults. The items are based on a qualitative interview with 12 patients with COPD, and a panel of 24 experts then rated the elements for relevance. So what we see here is the items based on something, a lived experience, and then items rated by experts. So what we have is face validity. The qualitative work created face validity for the instrument, but then there's also content validity because of the expert analysis of the instrument. Okay, let's look at this one, construct validity. So development of a cane use cognitive mediator instrument. It measures the cognitive determinants of cane use in older adults, and it was validated by contrasting mean scores of cane users with non-cane users. So in this case, you would think that cane users probably have a higher score than non-cane users. And if you administer them to both, then you might be able to predict who's going to use the cane you've instructed them in versus the other. So let's take a look. Construct, it's a known group. So you take someone who has that particular behavior of using a cane, and notice this is a human attribute, very difficult to measure. And so they use the people using the cane, and if they get a much higher score on this instrument than people who eventually do not use the cane, you can administer the tool and predict who will be a cane user and who will not use the tool. So this is how a lot of instruments are used in nursing practice. And let's now look at criterion-related validity. Here, there were revised scales measuring women's perceived susceptibility to breast cancer and perceived benefits and barriers to using mammograms. It was validated by examining the scale scores in relation to the actual mammogram compliance. So notice this is something that's very observable in the world, and they use the scales and related to that. And so using the mammograms as the gold standard, they looked at the person scores and related them to them. So in this case, it was predictive of the behavior of using the mammogram. Well, the important thing to remember on these, again, you want to use the term supported. So validity and reliability are not inherent characteristics of these instruments, but these different procedures we take support the validity, support the reliability, and the administration of the instrument is validated and connected to reliability. So none of this information is proven, it's simply supported. All right, so here's how we critique the data collection. Did the research report provide information on that whole process, who, what, where, when, why, how they did that? That's on those data collection slides that we looked at earlier. And then was there appropriate level of measurement? Remember, you want to use the highest measurement possible and not just place things in the nominal or that low level measurement. And did they provide description of reliability and validity in the research report? Let's talk now about qualitative data. And remember, this is found on pages 205 295 and 296 in your textbook. And the real question with qualitative data is, does this data reflect the truth? There's 4 criteria to evaluate called to evaluate the trustworthiness: credibility, dependability, confirmability, and transferability. So credibility is how believable are the findings, and was there a lot of engagement and study about the topic? Were there many different forms of measurement, external checks, ways to confirm the evidence, and how credible is the researcher in the topic? Then there's dependability, and that's similar to stability. Basically, if you were to go and study the same kind of issue, would it be the same over time? Could you replicate the findings again? And how is the data auditable, which means can you go back and see exactly how the person collected the data and collect it the same way? And the third and fourth, confirmability, means was the person objective or did they remain neutral? Did they discuss their own bias in the data collection? And then transferability is the extent to which findings can be transferred to other settings. And we've spoken about these terms before, and transferability is the qualitative term for generalizability. So remember, if you're having a qualitative term, you would never critique it and say it's not generalizable, but you could critique it if you believed it was not transferable. So certain words are used in the critique of research reports based on the type of study that you have. So today we learned about measurement. You learned in qualitative data that there's 4 levels of measurement. We discussed reliability related to the alpha coefficient, and validity, the face, content, construct, and criterion validity. It looks like I left a word off that slide. And then quantitative data is the trustworthiness. And here we go. This slide is wrong, so I will correct this on the other slides, but I do not have the opportunity to correct it for this recording. But notice that qualitative and quantitative are reversed on this slide because qualitative data relates to trustworthiness, credibility, dependability, confirmability, and transferability. My apologies on that slide. I will fix it in the other deck.